Okay, before we talk about box plots, we're going to define, finally, these measures of central tendencies, or just where is the center of my data. Finally, here's the definition of a mean. We haven't even defined it yet, though we've been talking about it a lot. But this is what the mean is. It's just add up all the values divided by the number of data values. You get your average number per whatever amount of data units that you have. Okay, there are symbols that we will use for mean in this class. This symbol is a mu. It's like a U with just an extra little line like that. And then an X bar. We call that X bar. We'll talk about that later in this class. And then the median is the middle data value of a set of data. If you can't find the middle value because you have an even number of data points, you will average the middle two values and you'll find a middle data value. Five numbers to find the mean, add them together, divide by 5. You'd get 20.4. If you wanted to find the median, what I like to do is just start crossing out from the outside, working my way inside until I see my middle data point. And this would be the median. If I had an odd number, an even number, this is 5 data points, this would be the middle. If I had an even number, let's say I add 42 to this, I'd have 1942, 2038, and then I'd have 2 middle numbers. If I have 2 middle numbers, you would have to average those 2 middle numbers together. Here the median would be 20.5, which is just 20 plus 21 divided by 2. Okay. What's great about the median is that it's right in the middle of your data. You know that half of your data will be below the median and half of your data will be above the median. You can't necessarily say that with the mean, depending on how your data is distributed. Okay. We call the median a resistant statistic. It's resistant to outliers and effects of outliers on your center. Okay? Median is resistant. We call the mean not resistant because the mean is affected by outliers. Outliers will move your mean one way or the other, creating the skewed data set that we talked about last class. Skewed left if we have low outliers, skewed right if we have high outliers. And what is it resistant? It's resistant to outliers. Make sure we include that we are talking about extreme values, outliers. Okay, again, you don't have to copy everything down, but usually the stuff that I underline, that's important. That's what you should get down. Okay, moving forward. Before we move forward, this is a good one. A little math humor. Should we scare the opposition by announcing our mean height or lull them by announcing our median height? The opposition would be scared if we use the mean, because this is a really tall dude. He would affect the center of your data. He would skew your data to the right. So all of a sudden you would be able to say, you know, the average height of our team is 6 feet when these guys are all, you know, 5'2", nobodies on the basketball court. Okay. If you wanted to announce, oh, you know, really the median of all of our heights is 5'2", then all of a sudden, your opponents wouldn't know that you had an outlier. Just interesting. Okay, we will be looking at box plots, and box plots will be able to show you whether you're skewed left, skewed right, or skewed in the middle. I don't love looking at a box plot to show the skewness. I prefer histograms or even the stem plots. But I'll just show you that after we graph these box plots, we'll be able to see that our data will be skewed to the left, symmetric, and skewed to the right based on the location of our median in comparison to the rest of our data. Okay? But let's now talk about box plots. Okay? Here's a box plot. There are 3 box plots here. These are the test scores of Ms. Hall's first, second, and third period classes from the last test. Okay? What it shows is a bunch of things. It shows how your data is kind of distributed, so almost similar to a histogram. It shows where your data is located. We will have maxes and mins that we'll be able to see. We'll be able to see if there's any outliers. And it's all stuff that we look at. And it's all good stuff. Now, go ahead and kind of sketch one down. I'm going to list the important data points that are shown on this box plot. Okay, and there could be like a dot on the side. It all starts with a median. And your median of your data set ends up being the line that is inside of your box. Well, after we have our median, we know that 50% of our data is to the left of the median, and 50% is to the right. And that's important to know. It's like, okay, this is the middle number. Half my data is above this, half my data is below. Well, we go a little bit further in depth into how my data is distributed because we get this Q1 value and this Q3 value. The Q1 value is just the median of your bottom half of your data. Q3 is the median of the top half of your data. So we end up having 3 different medians. We have the median of our overall data set, and then we have the median of our lower half of the data. And this would be the median of the top. What is that? What did I just write down? Is that top? Yeah. Okay, good. All right. Sometimes. These are either the max or min values. This is a max value because it's the last value here. In this situation, we will be able to see outliers, which would be the min value on the low side, and this would just be the first non-outlier. Okay, outliers being the dots past the end of the whiskers. And in the past, we kind of like just looked at our data and said, oh, this must be an outlier. But today, we will actually define what an outlier is going to be and a way to calculate and see if we will have an outlier or not. Okay? Yeah, these are the whiskers. This is the box. The whisker just kind of shows you where how far your data is spread out between your median and then your max and your mins. Okay. Those are the numbers. That's the 5 main points of the box plots. We call Q1 sometimes the 25th percentile because 25% of the data is underneath Q1. The median, the 50%, because 50% of the data is underneath the median, and the Q3 as the 75th percentile. And you probably don't understand the whole 50%, 75%, 25% thing right now, but when we find the median and the Q1 and the Q3, you'll see, oh, okay, that makes sense. Half of my data is under here, and then a quarter of my data is under here, okay? And this is how you do it. Order the data from least to greatest, find the middle number. Q1 is the median of the lower half, Q3 is the median of the top half. Okay, this is important. The interquartile range, which is the Q3, the median of the top half, minus the Q1, the median of the bottom half. That's the interquartile range. It's the range of the box. This is important because it shows how far away 50% of the data is. Okay, we know 50% of the data is in this box. Well, if we take and find the interquartile range and multiply it by 1.5, we will have an outlier, or kind of a range for our outliers. We'll take 1.5 multiplied by IQR, and that will help find our outliers. You will take your Q1 value, subtract 1.5 times your IQR. That will be the low end of where your data is considered to be not an outlier. You will take Q3 and you'll add 1.5 times the IQR to see the high end of the range. And outliers would be outside of those ends. Okay, that's a lot. Let's do some calculations. Go ahead and write down this data set. 5, 5, 6. Go ahead and add a -3. And throw in a 16. We'll see if this works out nicely. Okay, so we got -3, 5, 5, 6, 7, 8, 9, 9, 10, 10, 12, 12, 16, and 30. Question? What was higher than? Higher than Q3 plus the 1.5 times the IQR. That is how we'll find outliers on the upper end. Okay, now we're going to find this 5-number summary. Okay, first thing is to find the median. Everybody find the median of this data set. Go. We should get the median as 9. We ended up with 2 values in the middle, but they were both 9. If I average those 2 values, we'll get 9. Okay? Now, here is the great part about being the median. The median will split your data in half. All of a sudden, after you write down where the median is, you can just draw a line right through that median. And as you notice, we have the same amount of data points above it and the same amount of data points below it. So we split up our data into halves. Well, if we find the medians of our halves, we will find Q1 and Q3. So find the median of the lower half and find the median of the upper half and check your answer with a neighbor. Check your answers with a neighbor. What do we get? 6 and 12. Excellent. We got -3 and 9, 5 and 8, 5 and 7, 6, the middle one, 9 and 13, 10 and 16, 10 and 12, and 12. So this ends up, when we split it in half, we had odd numbers, which means we could find the middle point, okay? These are great numbers. This is telling me that a quarter of my data will be under that Q1. A quarter of my data will be above that 12, okay? The next thing we need to calculate is the interquartile range, IQR. We have all of what we need to find the IQR. IQR is just your Q3 minus your Q1. This is 12 minus 6, which is 6. That will be the length of my box. Well, the next value we need to find is 1.5 times my IQR. This will help determine outliers. It'd be 1.5 times 6. You'd end up getting 9, correct? Okay. We will take our Q3 and add 9. We will take our Q1 and subtract 9. And if we have values outside of that range, then all of a sudden we would consider that an outlier. Yes? Right, because we have -3. You know what? It's one of those things where it should just be outside. So they're probably going to list this as not an outlier. But let's just make it obvious. Let's change this to -4. Okay, and it'll be obvious. So if I take my Q3 and add 9, I get 12 plus 9, which is 21. Any values above 21 would be considered outliers. I look and I see I have a value 30. Now you guys could have probably just looked at this and seen 30 and been like, yeah, 30 is an outlier. Sure. But this is now kind of a formulaic mathematical way of proving that this is indeed an outlier. You would say, okay, 30 is bigger than 21. 30 is an outlier. We will take our Q1 and we will subtract 9. And I get -3. Well, if we had -3 and this is -3, then it technically is not outside of that value. So we would say -3 is not an outlier. But since I changed it to -4, you would say -4, which is less than -3, is an outlier. Does that make sense? Okay. The next data set. It's important to know if you have a median that's in the middle. So we have 1, 1, 2, 4, 5, 6, 7, 8, 8, 10, and 11. If I found the median, it would be where? Six, right? Here's a very, very important next step. You would put a line through 6, and you would not be including 6 to split up your data. Okay? Don't include 6 to find the median of the top half. Don't include 6 to find the median of the bottom half. So maybe write a little note. If your median is an actual middle number, that's kind of where your line goes through. Notice that this was between the two values to find the median. This is straight through these values to find them, to split it up. Okay? The median 6, Q1 would be 1, 5, 1, 4, 2. Q3 would be 7, 11, 8, 10, and 8. My interquartile range would be 6. Same thing with my 1.5 times my interquartile range. That would be 9. And then my high end range would be 3 plus 9, which is 12. My low end would be 2 minus 9, which is -7. I look at all my data points and I see I do not have any data points that are higher than 12 and lower than -7. So I say there are no outliers. Sorry, I chose red. Okay. Questions?
Where did the 3 come from on the high end?
Where did the 3 come from? It should be 8. 8 plus 9, 17. Thank you. I don't know where the 3 came from. Who knows? Okay? No outliers because there are no data points outside of the high end and the low end kind of range. Now that we have all this stuff, we are ready to make our box plots. Okay? We have our 5 summary values. We have our Q1, our Q3. We'll have our maxes and mins. We have our outliers for our dots, and we're going to make our box plot. So here we go. For the top data sets, what was the median? 9. Well then, right above 9 on an x-axis, and we can go by, tens. 10. Well, let's go by 5s. 5, 10, 15, 20, 25, 30. So right below 9, you will do your first line for your median. What was the Q1 value? 6. Do a line for your Q1. What was the Q3 value? 12. 5, 10, 11, 12. You've just created your box. If there are outliers, you will put them as dots. So at -4, there's a dot. At 30, there's a dot. Your whiskers will extend to all of the non-outlier points. So to the furthest non-outlier point that is above and below. Here, our biggest value is 16. So 5, 10, 15, I would have a whisker going to 16 because it's my largest value that is not an outlier. And then I would go down to 5, which is literally right like here. And you just create your box and whisker. Definitely skewed to the right. The whisker is very small on the left side. This outlier is huge on the right side. I would say the median is going to be pulled, the mean is going to be pulled to the right there. So we can do the same thing for the other one. Why don't you guys create the other box and whisker for the lower data set and compare your answer with the neighbor. The whiskers in this case will go to the max value and the min value because there are no outliers. Any questions? All right, well, that's all fun and all doing that by hand, but our calculator can do this as well. So let's get our calculators. Go ahead and enter this data set into your stat edit values. Yeah, include the -4. And discard the ink notations. So this is -4 and 16 is in here. I will do it with you. -4, enter. Anybody have problems going to stat edit? Stat edit. 5, 5, 6, 7, 8, 9, 9, 10. There's a cricket in my room. 10. Crickets are taking over the world. 12. 12. 16. 30. Okay, let's go into our stat plot. Let's make sure our plot 1 is on. If you go down to type, we will go to one of these two box and Lister plots. We're going to use this one on the left because it includes the outliers. Your calculator actually does the 1.5 times the interquartile range and will actually figure out which of the values you plugged in are outliers. To get there, you need to just keep going to the right. It doesn't go up and down. And press enter to select it. Any questions about this so far? The first one with the dots that will include the outliers. We then can graph and we can zoom stat, which is zoom 9. And your calculator does a great job of zooming. And we notice everything that we had down, the outliers, the dots, the lines, they have. It's pretty awesome. If you press trace, you will be able to see all of the different values. That outlier is at -4. This smallest data point before we got to an outlier is 5. Our Q1, the median of the lower half of the data, is 6. The median of our entire data set is 9. The median of our upper half of our data set is 12. The max value that is not an outlier is 16. And the outlier to the right is 30. Okay? Now, what's really cool is that we can have this one graph done. We could do this one as well, and we could put it on the same graph display. Let's go back into stat and go into edit. And let's enter in this data set into L2. Go back into stat plot. You can turn on another stat plot. You can go to plot 2 and say, you know what? I want a second stat graph so I can compare things. We'll turn on plot 2. And we will change the type to be the correct box plot type. Now the only thing you have to change is that you have to tell your calculator, for this box plot, we need to use the second list, the L2 list. Okay, the L2 list is for that one. So what you got to do is go to where we're taking our data, our X list, and type in L2. Now you're not going to type in L then 2. You're going to find L2 right here in blue above 2. Okay, so you go second, 2, and that's L2. And then you graph. You can zoom 9 to see if it changes at all. Nope, good. And trace will work. You just have to go up and down to access your other values. What's your guess? Okay. Everybody confirm with your neighbor that we have 2 graphs that look just like this, and if not, please help each other out.
So it's,
okay, so you got
I
the first one.
right. It's the second one.
Right, so we need to go to the second plot and turn this on.
Oh, okay.
Okay, and then we'll select the correct graph. You have the correct list.
Okay.
Now you have two. Any questions? Any issues?
Mine says graph is in mismatch. I don't know what that means.
It's because you turned on your third plot, which you need X's and Y's there. Okay, zoom 9. Yes.
Like 2 and 3.
Where is your L1? Somehow it deleted, so you're going to have to go and either restart, but you'll have to go L2 for the first one, and then for the second one, you'll do L3. Right? And there you go. I would reset your calculator, and your L1 will pop back up. Any other questions, difficulties, issues? Okay, yes. On your calculator, let's figure this out.
Not the outliers one.
No, the one on the right. That's the one. Now try. We're good?
Oh.
Sweet. Zoom 9. Remember to zoom 9 to see everything. You can go up and down to look at the median, the Q1, the max, and stuff like that for both of them. Okay? So, your turn. I want you to make and compare box plots for the poverty rates in the eastern United States, split by southern, southeastern states and northeastern states. And I want us to compare the distribution of the data for this. Yes, I want you to make 2 different box plots, one for southern, one for northern. On your calculator, right? I mean, you can find this without a calculator, but now that we have this ability, let's just do it. Right. Really quickly, before I zoom in, what's the quick way to delete data points? Go all the way up to the top and press clear. Go all the way up to the top and press clear. Oh, this is so much faster. What was I doing? We have 12 data points and 12 and 14, right? Let me see your graphs. I'll show you my graph. What? Oh. That's what my graphs look like.
Oh, wait.
Sorry. Here. Press enter. Beautiful. Let me see it on everybody's. Excellent. Excellent. Perfect. Now just zoom 9 and it'll make it nice. Okay, what you notice is that the southern states, most of their data is much, much higher than the northern states. The northern states does have an outlier, which is New York for poverty rates. But, now we can easily look at distributions of data using these box plots and compare them. We can compare 2, we can compare 3. We have as many as 1, 2, 3, 4 box plots that we can have on. Okay, so 4 histograms you can compare. And that's it, but it's really, really important before I just give you your homework and you guys start working on your homework. It's really, really good to understand what the lines mean and how what the lines do is they split up your data into like half of my data is below the median, half of my data is above. A quarter of my data is in here, a quarter of my data is here, a quarter of my data is here, a quarter of my data is here. That's what you do by taking the median and then taking the middle of your top and the bottom. You split it into fourths. Okay, so we split the data into fourths so we know 50% of our data is between that Q1 and that Q3 of that top values, which is 50% of the southern, southeastern states have poverty rates before 9, from 9 to 13.3%. Like that's important to know. Half of the southeastern U.S. states have poverty rates greater than 10.5. Okay, that's the idea with these box plots. They really show you the distributions of the data and the percentages that your data is, and you can just write down a lot of different, good statistics. 25% of your data of the southeastern U.S. states have poverty rates greater than 13.3%. Okay, good. Here's your homework. It is a worksheet as well as a couple book problems. Please start that and work on it during CAF time.